Hello. Today you're going to learn about atmospheric pollution. And you should have downloaded the document where you're going to write your notes. And feel free to pause the video so you have time to write, and also review sections of the video when you need to make sure you've got all the information. So let's get started. These first few slides, you're not going to write anything down. It's just to give you some background and for you to realize what a big issue atmospheric pollution really is. So worldwide, about 9 million people die every year from air pollution. And just so you realize, China is notorious for its poor air pollution, but as you can see from this graph, many other countries, including the United States, have a big issue with air pollution. It's a very expensive problem. And if you look at deaths due to ambient air pollution, notice the United States has quite a problem. Not as bad as some other parts of the world, but we have our air pollution problems as well. If you go back to the 1919 flu pandemic, the cities with the highest coal pollution saw 10% higher mortality rates. And if we fast forward to today with our COVID-19 pandemic, the cities with the higher fine particle air pollution, we'll learn about that, particulate matter, they have 8% higher mortality rates. So air pollution definitely affects mortality. What is your chance of dying, especially in a pandemic, and especially when the virus is a respiratory virus? So if we look at hospital visits and we superimpose that with sulfur dioxide, which you will learn more about coming up, this is looking at Louisville, Kentucky, and they have coal plants there for electricity, and they put retrofits, so they were scrubbing the pollution that was coming out of their smokestacks. That happened in 2015. They also had some retirements of the oldest, most polluting coal-fired power plants. And look at what happened. If we look at the hospital admissions, and this is asthma related, they certainly seem to track with the sulfur dioxide emissions. And today, 45% of the US population lives in counties that don't meet EPA air quality standards. So we most definitely have an issue with air pollution in the United States. And when pregnant women are exposed to air pollution, they are more likely, their children are more likely to have high blood pressure. We know that air pollution damages the hearts and brains of people who live in polluted areas. And we have found particulates in children as young as 3 years old. This is looking at Minnesota, but it's most likely true in other places as well. If you look at the statewide average, 32% of the population lives in higher polluted areas. But if you look at low-income communities, 46% are in high pollution areas. And indigenous and communities of color, 91%. So this is very much a social justice issue, or sometimes we call it environmental justice. And if we look at African American children suffering from asthma, there's twice as many children African American children that have asthma compared to white children, and their death rate is 10 times higher. Another social justice issue. And this is Cesar Chavez High School in Houston, Texas. There are 4 chemical plants surrounding this high school, and it is a mostly Hispanic population at the school. Now let's take a look worldwide at some other examples of air pollution. Hanoi, Vietnam, they only had 38 days of clean air when measured by the World Health Organization standards. That was in 2017. Warsaw, Poland, babies born today have the equivalent of 1,000 cigarettes, smoking 1,000 cigarettes in their first year of life. Their air quality is so poor. And in India, roughly 1.2 million people died in 2017 from air pollution. That's 13% of all deaths. So air pollution is a big, big problem. And this is where you're going to start writing down notes on your document. So we did cover this earlier in the Earth Systems unit. So this should be a review to you, but it's always good to get a review. So the layers of the atmosphere. The troposphere is the layer closest to the Earth. Most of the air's mass is in the troposphere. And it goes anywhere from 17 kilometers above the oceans and equators, and it's closer to the Earth at the poles. It's about 8 kilometers above the poles. And that's where weather and the cycling of chemicals occurs. And generally, the pollutants that we are putting into the atmosphere, they stay in the troposphere. Not all of them, but that's where they generally stay. So we're talking mostly about the troposphere. But above the troposphere is the stratosphere. And that is also important. It goes anywhere from 7 to 48 kilometers above the Earth's surface. And that's where the ozone layer is. The ozone layer is in the lower part of the stratosphere, just above the troposphere. And that's very important. And we're going to be talking about ozone towards the end of these notes. We have talked about it before, so that will be a review for you too. So I'd like you to watch a short video clip about toxic smog in China. The link is in your document, and you should write notes in the box. So now that you've watched that video on smog in China, I have a few questions that I'd like you to think about. And you don't need to write these down on your notes. But do we in the US have a part in the pollution problem in China and also in other developing countries? You don't need to write down your answer to that question, but I do want you to pause the video and think about it. Here's another question. Are we affected by the pollution in China and other Asian countries? The poorest people are the most affected by pollution, making it a social justice issue. Should everyone, even the rich, care? Should wealthy countries help developing nations get through the industrial transition? So those are all some important questions that we should all think about. Here's another video for you to watch, because I always try to keep what we're learning close to home in California. And we have some very, very bad air pollution in California, especially with wildfires increasing. That's making our air pollution worse. The link to this video is on your document, and take notes in the box. Before we move on to the next section, I'd like you to just pause the video and think, what are the sources of air pollution? Name as many as you can. And I want you to think about natural sources of air pollution, and then also anthropogenic or human-caused sources of air pollution. So let's see how you did. And you should write these down on your notes. So some natural sources of air pollution. Volcanoes. Some very dangerous gases can come out of volcanoes, and a large volcanic eruption that sends the sulfur dioxide all the way up into the stratosphere can actually cool the planet for years. Wildfires, that was a hint. Earlier I told you that as our wildfires are getting worse in California, so is our air pollution. Wind-blown soil puts a lot of particulates into the air. Sea salt spray for those near the ocean. And then organic compounds from plants. Now, some anthropogenic sources of air pollution. Burning fossil fuels, that is the biggest one. Then industrial facilities, agriculture, landfills, and also waste incineration. Now, when we talk about air pollutants, there's two categories that you need to be aware of. So one of them is what we call primary air pollutants. Those are the chemicals that we release directly into the air. And I'll give you some examples of those. And then the other category is secondary pollutants. So those form when the primary pollutants react with other molecules in the atmosphere. We're going to first take a look at some of the primary pollutants. So one of them is sulfur dioxide. That's the most common of the sulfur chemicals. Sometimes you'll see those written as sulfur and oxygen with an X because it can have a different number of oxygens. They usually come from burning sulfur-containing fossil fuels, especially coal, but some gasolines have a lot of sulfur in them. And then also smelting ores when you're separating metals from the ore. So, and then the sulfur dioxide is the primary pollutant, but when it gets into the atmosphere, it can form secondary pollutants. So that sulfur dioxide will react with different chemicals in the air, and they can form sulfuric acid, which is a component of acid rain, which you'll learn about later. It has a lot of negative effects on the environment. And then also ammonium sulfate. That's a particulate, and it forms a haze. It's part of industrial smog, and it can get deep into the lungs and cause a lot of health issues, which you'll learn about in a moment. Another primary pollutant is nitrogen dioxide, and those are formed, sometimes they're called NOx, N-O-X, because again, it can have a different number of oxygens. So the most common is nitrogen dioxide, and then another common one is nitric oxide. So these are also released from burning fossil fuels. They're highly reactive, so they form all different kinds of secondary pollutants. So the most common is nitrous oxide, N2O. Nitric acid, another part of acid rain. Nitrous acid, also part of acid rain. And then there's many more. And so often you'll just see NOx because there's so many different chemicals, primary and also secondary pollutants. Another primary pollutant is carbon monoxide. And this one's particularly dangerous. It's formed from the partial combustion of fuel. So there's not enough oxygen to form carbon dioxide, so carbon monoxide is formed. It's going to happen in engines, also in fires, wildfires. It's so dangerous because it's colorless, odorless, tasteless, but it's highly toxic. So, and the reason it is so dangerous is because if hemoglobin has the opportunity to bond with either oxygen or carbon monoxide, it will bond to carbon monoxide first, and it holds very tightly to that carbon monoxide. So it doesn't, the blood doesn't just come back to your lungs and release the carbon monoxide back out into the air. It holds onto it. So you can get carbon monoxide poisoning when there's plenty of oxygen in the air, but your hemoglobin's holding on to that carbon monoxide and you're suffocating. Right? So it's very, very dangerous. Another primary pollutant is what we call volatile organic compounds, VOCs. So these are organic chemicals. They've got carbon in them, and they have a high vapor pressure. So at room temperature, they very quickly evaporate and turn into a gas. That's why we call them volatile, because they turn into a gas very quickly. They can be natural or they can be man-made. Scents are usually VOCs, so perfumes and scents and shampoos. That's why we smell them, because they turn into a gas very quickly. They can be very dangerous to human health and also to the environment. And there's all different places they come from. They come from vehicles, from industrial processes, solvents, things like paints, anything that's got a lot of smell to it. Another primary pollutant is particulate matter. So these we categorize by size. And here's a human hair, just so you can get an idea of just how small they are. So a particulate matter of 10 is 10 micrometers. And that's things like dust and pollen. They're pretty large, so they can be filtered out by the hair and mucus in your nose. But smaller ones, like particulate matter 2.5, those are so small, they're not caught by the hair and mucus in your nose, and they get right down deep into your lungs. And they are particularly problematic. They can be many different sizes and shapes. They can be made up of hundreds of different molecules. It's really just, they're small, and you can breathe them in. So where do they come from? All sorts of things. Construction sites, unpaved roads, fields, smokestacks, fires. These are a huge problem when there's wildfires. So when you're looking at the air quality during fire season in California, this is what we are primarily concerned with, the particulate matter. Now, this video is great. It shows you just how dangerous and why these particulate matters, especially the really small particulate matters, are such a problem. So you watch this video, the link is in your document, and write notes in the table. After watching this video, I hope that when there is a fire, you will not go outside without a mask on. We're all getting more accustomed to masks these days, thanks to COVID-19. So wear your mask when the air quality is bad because of fires. Another primary pollutant, one that thankfully we don't need to worry about quite so much these days, is lead. Lead used to be in gasoline and paints, and thank goodness it was removed. So low levels in the atmosphere can build up in soil and water sources because it's heavy, so it falls out of the air and it collects in soil and water sources. And it's a neurotoxin that damages brain cells. So in the 1970s, it was removed from paint, and it was removed from gasoline in the 1980s. So today, very quickly, the amount of lead in children's blood went down after it was removed from paint and gasoline. It's really only a problem in older homes that are being remodeled. And I don't know if you remember a video I showed you about a battery recycling plant in East Los Angeles. And as they were recycling these lead batteries, the community around this recycling plant just got covered in lead, terrible amounts of lead. And it's costing the state of California a lot of money to clean it up. So now on to secondary pollutants. So these are not released directly into the air, but they come from chemical reactions in the atmosphere. So in this picture of our beautiful Golden Gate Bridge, see that brown haze? That is something called photochemical smog. So this is a chemical reaction that forms between volatile organic compounds and nitrogen oxides, those NOx chemicals. And it only happens in sunlight. It needs ultraviolet light, and it forms both ozone and airborne particles. So it looks like a brown haze. It only occurs in sunny, dry climates. And you've got to have the VOCs coming out of vehicles that are burning gasoline. So we get this kind of fog in California. Los Angeles was notorious for photochemical smog. It's warm, dry areas. Very, very harmful to the respiratory system. Now, I want you to pause the video and take a look at this graph. So what season is ozone the highest? And why do you think that is? So notice ozone is highest in the summer months. And why is that? It's because to make this photochemical smog, you need dry, warm climates with lots of ultraviolet light. And when do we get that? We get that in the summer. And so that's when the ozone levels spike. And ozone, we want it up in the stratosphere, which we'll talk about it in a moment. But down in the troposphere, it's a secondary pollutant that's very, very harmful to lungs. Now, there's another kind of secondary pollutant called industrial smog. Sometimes it's called sulfurous smog. And it looks to us very similar, like a brown haze in the atmosphere, but it's actually very different. So it's made from sulfur dioxide and particulates, usually from burning coal and other high sulfur or fossil fuels, and also from smelters. And they combine to the moisture in the air. And that's the difference. This kind of smog, industrial smog, happens where there's moist climates. Photochemical smog happens where it's dry climates. This forms acid rain, and we're going to talk about acid rain coming up in a moment. Very damaging to the environment and structures. It also forms ammonium sulfate particulates, and that's what gives it the haze, the brown haze. They're so small that they can get deep into your lungs and be very, very harmful. So you usually find this industrial smog in areas with a lot of factories and urban areas with lots of traffic as well. So now let's take a look at what acid rain does. So it formed from both sulfur dioxide and the nitrogen oxides. And those will react with water in the atmosphere and make sulfuric acid and nitric acid. And it does cause respiratory problems for humans, but it also damages structures. So you can see this marble statue and what's happened because of acid rain dissolving the marble. Marble's made from metamorphosized limestone, and acid will dissolve limestone, which was originally made from seashells. So it's a sedimentary rock made from seashells. So not only that, though, acid rain, yes, it damages structures, but also when acid rain gets into soil, it leaches out metals that are naturally in the soil and nutrients that are in the soil. So it weakens the plants. Plants generally don't die from acid rain, but they're weakened because the soil is so nutrient poor. And then a disease can kill the plants. So it's also the aluminum and other metals that get leached out of the soil from the acid rain. They accumulate in lakes and rivers and can become toxic to the aquatic life. So sometimes the water becomes so acidic from acid rain that a lot of living things can't live in the water, but usually it's the metals that are leached out of the soil that kill the aquatic life. So if you look at this graph, or it's not exactly a graph, but you'll see that we've made a lot of improvements. So going through the decades, from 1988 to 2008, we have a lot less acid deposition. So that's when acidic molecules in the atmosphere fall down onto the earth. Much less of that in both sulfate and nitrate ions. So we're doing much better than we were. That's a good news. Take a look at this video from National Geographic so you can get an overview of the different air pollutants and put the notes in the table on your paper. Here's another video for you about the health effects of smog. And again, you'll take notes in the video, or I'm sorry, notes on your document. So the US was getting some really bad air quality. And in the 1970, the Environmental Protection Agency was created. And the first job of the Environmental Protection Agency was to enforce the Clean Air Act, which had just been passed. So we're going to talk a little bit about that Clean Air Act, one of the great pieces of legislation that has really made a difference in our country. So the Clean Air Act required the EPA to set limits for 6 criteria air pollutants. So these were the pollutants that were the most significant to human health and also the health of the environment. So these are the ones that we covered at the beginning of these notes. So sulfur dioxide, carbon monoxide, particulate matter, ozone, nitrogen oxides, lead. And they had to set two different standards. So there are primary standards which protect human health, and then there's secondary standards that prevent environmental and property damage. Now, don't get mixed up with primary pollutants. Those are the chemicals that we are actually releasing from tailpipes and smokestacks, and secondary pollutants, which are made from chemical reactions in the atmosphere. These are different. So these are the limits set for by the EPA for these 6 criteria air pollutants. So the primary standard protects human health, and the secondary standard, which is generally a little higher, protects the environment and property damage. So, and then in 1990, there were some amendments made. So these provided some additional standards for some new other chemicals that we realized are really harmful. So one was ozone depleting chemicals, and we'll talk about those in a moment, and acid rain. So the Clean Air Act, there's different things that we've done to clean up our air because of the Clean Air Act. And let's go through how we've improved our air quality in this country. Not that our air quality is great, but it's better than it could be. So generally, remember, most of our air pollutants are caused from burning fossil fuels. So anything that we do, to conserve energy, then we're burning less fossil fuels. So energy conservation, remember, those are just changing habits, turning off lights, driving less, shorter showers, those kinds of things. So think back to our energy unit. And then there's energy efficiency. Energy conservation generally doesn't cost any money. Energy efficiency sometimes does cost money because you have to purchase more energy efficient appliances or vehicles or light bulbs. Another thing we've done is move to alternative fuels. So some fuels are just cleaner than others. So here are some various fuels and how much we use them. Another thing we've done is vapor recovery nozzles. You'll see these when you fill up your gas tank. So gasoline will vaporize very quickly and go into the air, and it's polluting. So there is a nozzle that will collect those vapors and move them back into the tank underground. So that's really helped our air quality. The catalytic converter was a huge, huge improvement. All the gases from your engine go through the catalytic converter, and it reduces the tailpipe emissions by about 90%. It was one of the great inventions. Other things are in factories. So wet and dry scrubbers on smokestacks. They can spray water in a wet scrubber, spray water through the air coming out of a smokestack, and a lot of the particulates will collect in the water. Of course, then you've got to deal with the water and all the particulates in there. And then there's dry scrubbers, which use chemical reactions. So an example of that is electrostatic precipitators. So the gases coming out of a factory go through these metal plates that have charges on them. And so a lot of the The particles have a charge and opposites attract. So the particulates will be attracted to the metal plates, and the gases coming out are then particulate free. There are some geologic areas or geographic areas that are just more prone to pollution. So Los Angeles is an example. It's in a basin, and they used to have terrible, terrible photochemical smog. It's gotten better, but here's one of the problems that happens. It's called a thermal inversion. So normally you'd have warm air on the ground, and the warm air rises and carries away a lot of the pollution. But sometimes you have a thermal inversion. So what is that? That's when warm air moves over cold air and traps the pollution near the ground. So you can see that in the picture. There's high air pressure pushing down. There's a layer of warm air, and it's trapping the cold air. Believe it or not, warm air and cold air don't mix very well, and that traps the pollutants near the ground. And that's generally urban areas that have a lot of vehicles and industry, and they're surrounded by mountains. They are particularly bad with these thermal inversions trapping the air pollutants. All right, once before we talked about the ozone layer. It's up in the lower part of the stratosphere. And you're not with your desk partners, but I'd like you to pause the video and think back. What do you remember about ozone? So there's two kinds of ozone. There's ozone up in the stratosphere that's really good and protects us. And then there's ozone, what we call ground level ozone, which is a secondary air pollutant and is really bad to breathe in. So what do you remember about the ozone layer and what it does? So let's review what we learned about before and see how much you remember. So remember, ozone is O3. So it's 3 oxygen molecules bonded together. The oxygen gas that we breathe in and are dependent on is O2. So up in the stratosphere, ozone protects us from ultraviolet light. There's 3 kinds of ultraviolet light that comes from the sun. One is UVA, and it's anywhere from 400 to 315 nanometers. So it's a longer wavelength of light, and that means it's got less energy in it. However, it has enough energy to cause wrinkles and also some DNA damage. It doesn't cause sunburns, interestingly. So you don't even know you're getting the damage from this because you're not getting a burn, but long term it causes wrinkles and DNA damage. This one is not filtered out, or not much, by the ozone layer in the stratosphere. So 95% of this reaches the Earth's surface. Now there's a slightly smaller wavelength of light. It's called UVB. It's anywhere from 315 to 280 nanometers. And so that means it's got more energy than UVA. It does cause sunburn. So at least you know you're getting this because you get burned from it. It also causes cataracts. So in your eye, it discolors the cornea of your eye and makes it hard to see. And it damages the lens in your eye. That's what the cataracts are. It causes your immune system to not work as well, damages DNA, and therefore it leads to skin cancer more than UVA does. Now, most of this is filtered out by the ozone layer, so only 3% makes it to the Earth's surface. That's a good thing because it's got more energy and can damage your skin more. Then there's UVC. That's 280 to 100 nanometers long, which means it's shorter and it's very high energy. You don't hear about this because it is 100% filtered out by the ozone layer. So, and thank goodness, because it is very dangerous to living things. Now, what's the concern with ozone? There are some man-made chemicals that damage ozone. And so these chemicals are anything that contains nitric oxide, NO, nitrous oxide, N2O, hydroxyl, which is an OH, chlorine, which is abbreviated Cl, and then bromine. And all of these chemicals that contain these can break down ozone. They can rip off an oxygen atom by bonding with it and turn ozone into just regular old oxygen gas, which is not going to protect us from the ozone, from ultraviolet light. To give you an example of how dangerous these are, one chlorine from a chemical called chlorofluorocarbons, CFCs, can destroy 100,000 ozone molecules. And the CFCs can stay up in the atmosphere for a long, long time. Now, it was the late 1970s we realized that these chemicals were harming the ozone layer. So in 1987, world leaders from around the world gathered in Montreal, Canada, and every country agreed we need to phase out these chemicals that damage the ozone layer. And it's one of our environmental success stories. The ozone layer is thicker today than it has been in many years. So now a question for you. Does the ozone layer have anything to do with global warming? Pause the video and think about that for a moment and decide on an answer. So O3, ozone, it is a greenhouse gas. It does trap some heat, but it's high enough up in the stratosphere, stratospheric ozone, that it doesn't really trap that much heat. And ground level ozone doesn't trap that much. So it's critically important to life. Yes, it is a greenhouse gas, but it's not a major player in global warming. Now, there's some other kinds of pollutants that we haven't talked about yet, the indoor air pollution. And it's different in developing countries, low-income countries, and more wealthy countries. So when you look at this picture, you can kind of get an idea of what kind of pollution are they dealing with in their home. It's in general, indoor air pollutants are not well regulated, but because people spend so much time indoors, they're a huge impact on human health. So in low-income countries, the largest source is what they burn for heating their homes and cooking their food. Usually they're burning wood or charcoal or animal dung. And all of the particulate matters, the carbon monoxide, it collects in their homes because they're poorly ventilated. Whether it's where they work or where they're living, generally they don't have good ventilation. Now, if you look at this picture, in a high-income country, we also have indoor air pollution, but it's quite different. It's not from burning wood and charcoal and animal dung. It's other things in our buildings. One thing that's different is high-income countries, people spend a lot more time indoors, whether it's inside a building, like their home or their work, or inside a vehicle, commuting. And these indoor air pollutants are wide ranging. It can be asbestos, which is a natural, you know, molecule, and it can be dust or smoke, especially indoor smoking. It's also radon gas, and almost every state has a problem with radon. Some parts of the country, the Midwest and the northern states, have a bigger problem. Radon is a naturally occurring radioactive gas, and it enters through into buildings through cracks in the foundation. It also dissolves in groundwater. So the biggest problem is in basements and crawl spaces. So it's the largest cause of lung cancer in the US, bigger problem than smoking even. I'm sorry, it's the second largest. So I'm sorry, smoking is the largest cause. Another problem is mold inside homes, especially black mold. Volatile organic compounds. Think about anything like you get new carpets, new furniture, and the smell, new car smell. Those are volatile organic compounds. They're very harmful for you. So, and then can have a problem with carbon monoxide. Can be from tobacco, from um, from your gas furnace not burning correctly, and then also nitrogen oxides and sulfur dioxides from combustion. So it can be your furnace and also smoking. I don't know if you've ever thought about noise as a pollutant. It actually is. Noise pollution can be quite problematic. And you can study this chart. There's typical noises that our ears can handle no problem. When it gets a little louder than that, it can start becoming irritating. But beyond that, it can actually be hazardous. Your ear has these little hairs that move with the sound, and really loud noises can damage those hairs. And once they're damaged, they're never, ever replaced. So think about that. If you're listening to really loud music or you've got your earphones on and you've got them really loud, once you damage your hearing, you'll never get it back. So, but when we're talking about noise pollution, what are we talking about? They're sounds that are high enough to cause physiological stress, so they're bothering you, or they can cause hearing loss. So where do these come from? Transportation, so the buses going by, construction and the loud noises there, any kind of domestic or industrial activity. And they can have some pretty bad effects on animals. So they can cause animal stress. And the sounds that they normally use to communicate or to hunt are masked by these loud human-caused sounds. And it can actually change migratory routes. Actually, interestingly, with COVID-19 and so many activities being restricted because of the pandemic, they're noticing that birds are calling more loudly. I certainly felt like they were in the spring. And also areas that usually have a lot of tourism and whale watching, those boats are out and the whales are louder than they've ever been. And so this is giving animals an opportunity to live life without so much human interaction, and the animals are really doing well. I guess that's one positive thing for COVID-19. All right, you are done. So make sure that you submit your notes to Canvas, and I will see you back in class.